In this part, I will give you an alternate way to do Summer 2009 Math 263 Test 3 number 9C. Now if you see the standard way, which is done earlier, this is the way you do it. Okay, but this is the way I do it if I have not learned the change of variable. Now once we learn the change of variable and you want to use it, that's fine, and I will try to see what we can do. Now let's see. Let's go back. Notice that this is our domain, right? And so the volume of that integral, for the volume of the solid, will be integral, double integral of that domain, and then we have the area on the top. I mean the surface on the top, which is 8 minus x squared minus y squared minus x squared minus 3y squared, the plus 3y squared, dA in terms of d. Okay, now and then if I simplify that, I will get 8 minus 2x squared minus 4y squared dA, which I can factorize the 2 out. And if you want to, let's break that graph there into four parts, because again we know that this graph is symmetric with respect to xz axis, xc plane, and then the yc plane. Okay, so I'll break it into 4 parts, and this will be the d in quadrant 1 only, and then this will be 4 minus x squared minus 2y squared dA. Okay, now then we are now dealing with this ellipse, in which this is radical 2 and this is 2. Okay, only that part. Now but because this is part of an ellipse, then we can reparameterize this region here by x equals to 2r cosine theta and y equals to radical 2r sine theta. Okay, now it is not 2 cosine theta. If you use 2 cosine theta radical 2 sine theta, you will only get the arc there, the boundary only. Okay, but because we want to also include the rect part there, then we will use r, in which here the r is between 0 and 1, and the theta will be from 0 to pi over 2, right? Okay, now then we will use change of variable right now. Let me pull this out. We'll use change of variable right now. Let's see what we can do. If I do the Jacobian here, Jacobian of x, y respect to r theta, you will see that this is respect to r, this is 2 cosine theta, and this will be 2r negative 2r sine theta. This is radical 2 sine theta, and this is radical 2 cosine theta, r cosine theta. And if we go further, you will see this is basically 2 radical 2r. Okay, well, with some step in between. Now then at the same time, using that, then we have 4 minus x squared minus 2y squared. If I simplify that, x squared will give me 4r squared cosine squared theta, and 2y squared will give me likewise 4r squared sine squared theta, right? Which later on becomes 4 1 minus r squared. Okay, because this part here becomes 4r squared, right? I think I should take the negative also together, you know. That's what will happen. Now then the domain, the integral right now becomes 8 double integral 4 1 minus r squared. Okay, and this is the Jacobian 2 radical 2r d r d theta. and then the domain of the limits of integration, the theta will be from 0 to pi over 2, and the r will be from 0 to 1. Now I will now have 32, and the integrand and the inner integral independent of theta, I will take the pi over 2. Okay, and then here, oh, I still have 2 radical 2 there. 2 radical 2 integral from 0 to 1 of 1 minus r squared r dr. Okay, now then I now have 32 pi radical 2, and for that integration, what you're gonna do? Let's distribute the r there. 0 to 1. You can do substitution, but you may be thinking too hard to do that. And this will be 32 pi radical 2, and then I have 1/2 r minus 1/4 r to the, oh, I'm sorry, 1/2 r squared, and then from 0 to 1, 32 pi radical 2. This is 1/2 minus 1/4. That's equals to 1/4. Which is 8 radical 2 pi. Okay, now notice that that's the same answer we get earlier. Now this is what happens if we don't know a change of variable. Now the thing is, this change of variable that we did earlier here, okay, it's not something everybody can get right away. You need to get used to the way you see as an ellipse as actually a distorted circle. Okay, therefore when you try to reparameterize this, you can have a circle in mind, right? The way you parameterize a disk with distortion of that ellipse. Okay, and I hope you don't see that as a surprise, that because this is a circle, right, the way you parameterize a disk, then the Jacobian originally supposed to be with r only, with that distortion, 2 radical 2, they have that here. Okay, in other words, something we can do a little note in: if in future we have an ellipse that looks like this, if we have an ellipse that looks like this, let's say this is A and this is B here, okay, then the parameterization of that disk will be x equals to AR cosine theta, y equals to BR sine theta, okay, and the Jacobian of that will be, as you expect, this is ABR. Okay, and you can try. Okay, that's for this one. This is from summer 2009 Math 263 Test 3 number 9C, an alternate way to do this, provided you know how to do change of variable.